describe like all different types of things with just like in these terms. Book, an author has many books, and a book belongs to an author. A zoo has many animals, or something like this. You can imagine building a list to me. But then what do we think? There's like some relationships that we can't quite just describe like what this has many belongs to. So like, can anyone tell me the relationship between like doctors and patients? How do I clear this out? I can refresh the page. Yeah, so we have doctors and patients. And like, what does it mean? Like, how do we describe this kind of like in terms that we know, like has many or belongs to or something? Yeah, James.
The doctor has many patients.
The doctor has many patients. That's right. But it makes sense that like doctor like has patients, right? And a patient might like see many doctors. So we could almost imagine like something like this. And like this. Right? It's almost like a many-to-many relationship. Like it makes sense that a patient like has many doctors, and a doctor has many patients. And what if like I wanted to store? So if I'm a patient, I'm seeing a doctor, I have a doctor's method that returns the doctor. What if I wanted to know like what time I'm seeing that doctor, or like maybe I want to give a rating to my previous appointment with the doctor. Which model should be responsible for storing that data, the time I'm going to see this doctor? Any guesses, like here? You think you would store that on the patient, like what time I'm seeing the doctor? Yeah. Are we missing something? Is there a model we're missing here? Yeah. Exactly. Yeah. I think there's something. I don't actually know how to use this software, and I don't know how to erase stuff. There. Let's do this. Yeah. There's something we're missing here in the middle. This seems like incredibly tedious. There's probably a better. Yeah, let's start fresh. Okay. Cool. All right. There's what Kenny said like there's like we need like another class, another model. It makes sense. Like it doesn't seem like it's either the patient's responsibility or the doctor's responsibility to like know about. And I'm gonna use the word here like an appointments time or an appointments like rating or something like that. So what like models I feel like we're missing? Appointments. Yeah. Cool. We need like this thing in the middle, like an appointment. And we'll say a doctor has many appointments, right? A patient also has many appointments. And so a patient actually has many doctors through appointments. And that makes sense. It's only like I like have a doctor if I'm a patient by like scheduling an appointment with them. That's how how we get this like have relationship. Same thing with a doctor. A doctor has the patients because they went to an appointment with them. So another example of like a has many through would be like taxi drivers and passengers. What are those things joined by? How does a driver have passengers? Yeah. So we have an Uber driver table. We have an Uber passenger table, and like what other table do we need? Yeah, like a trip or a ride table or something like that, right? And that makes sense. Like, even just thinking about it, how you'd say it, you say like an Uber driver has many passengers through rides. Like that Uber driver has me as a passenger if I like went on the ride. So this is cool. So like, it's just two has many belongs to's, and then we're able to say this like has many through. So doctor has many appointments. Appointment belongs to a doctor. Appointment also belongs to a patient. So before when you said like yesterday when we said like a tweet belongs to a user, we like initialized the tweet like with a user object, right? We said like tweet.new. It took some content and it took a user. When we make a new appointment, we're gonna have to do something pretty similar. We're gonna have to say something like appointment.new. And if this thing, it belongs to the doctor and it belongs to a patient, we're gonna have to pass in both of those things, a doctor instance, a patient instance, and then any additional information like, perhaps the time of the appointment or something like that. 4 out of 5 stars or whatever, right? Cool. So keep this in mind. This is what we're going to approach here. I'm going to take the same problem from yesterday. this is exactly the same thing we did yesterday with the tweets and users, but we added a couple. We got asked to add a couple features. Yeah, here. A user should have an instance method called like tweets that returns a collection of tweet instances the user has liked. I also have tweet should have an instance method likers that should return a collection of user instances who have liked this tweet. Question number one, I'm thinking of like adding new features. I said, do I have to change my domain? Do I have to change my models? What do you guys think here? Anything that we need to add to be able to, I want this function. This is the feature we were asked to deliver. We need to be able to have like this idea of like likes. I should be able to, as a user, be like see all the tweets I like. That tweet should know about all the tweets I can't get.
But you need to have some functionality to like a tweet before you can figure out what has been liked.
Yeah, we would have to. We should like a user probably should also have like a user instance method called like tweet that like likes a given tweet. So like yeah, two things. I think that makes sense too. But like, why were we just talking about doctors, patients, and appointments? How can we relate that part of the discussion to like this domain? Yeah. We have a tweet class. We have a user class and a tweet class. But like, what's going to join this? The user has many liked tweets through what?
Database.
We don't have a database. We're sticking with repeater.
Given tweets has many likes.
There you go. Yeah. If a user is going to have many liked tweets like through likes, we're going to need a like model. We're going to need to say like a user has many likes. A user has many liked tweets through likes. A tweet has many likes. That makes sense, like right, the little heart and the number next to it. And a tweet has many likers through those likes, right? We're going to need to add like a like model here. Class like. Def initialize. And this thing, just like we were saying with the doctor appointments, the like belongs to a user. It needs to know about the user that like clicked like, and it belongs to a tweet. It needs to know about like what tweet this is about. So I'm going to have to pass these two things in when I initialize a tweet, a like. User and tweet. User is equal to user. Cool. I'm going to include this file here. All right, let's look back here. So we have this like model now, and we have to do this thing that Neil brought up. We'll have to call like, as a user, we want to be able to say .like tweet. What do you think that method should take as? Does that seem like that method needs any parameters? Yeah, I think it's gonna have to take a tweet, right? When we think about like what arguments a method need, like arguments are like a window through which you pass data to a method. If you need some data in the method, you probably should like pass it through as a parameter. So I think that's exactly right. We'll say def like tweet given some tweet. What do you guys think the implementation of this is going to be? What has to happen in this method? Yeah, Tim.
We should call to the like class and pass in that tweet to a method that's in the like.
I think so. I think I want to like create a like, right? Like I'm going to pass in. I'm going to say like.new, and I go here. Takes in the user and then the tweet. So what's going to go here in the blank? Self. Awesome. See, that's great. Already, like 2 days ago, that would have been like, much harder. Already, like so much better. That's great. Cool. So like, and this makes sense. I like to, like, the reason like we like talk about these relationships and like give them these names is because they're reusable and we can describe lots of different domains. So think about the kind of reciprocal method that we would be finding if I decided to do for our domain doctors, patients, and appointments or something like that. Imagine this was the patient class, and I said make appointment given a doctor. Well, that method would do the same thing. I would say appointment dot new. I would pass in self. I would pass in doctor, and perhaps this also takes like an appointment time or something like that, right? Like all the same stuff is going to apply no matter what the domain is, and that's actually why like these kind of relationships are like really powerful because we can keep using them for like lots of different problems. Cool. So a user should be able to like a tweet, which creates a new like object. Our goal is to write this method called user.likedTweets. Okay. Like tweet. I'm gonna write. So the first thing I just want to take care of just the has many belongs to a user before I even worry about like has many tweets has many like tweets through the likes. I just want to first know my relationship to likes, which is actually going to be like really, really basically the same as like this right here. When we wrote this, like a user has many tweets, I said, look through all the tweets, select the ones that belong to that user. This is exactly going to apply here when I try to find the likes that like this user has. Likes. And I'm going to look through all the likes, select the ones that belong to this user. This user. Cool. So this is going to look exactly like this method. Go to all my likes. I forgot that the like currently does not have that functionality. Let's add that. I'll shovel in self. We're going to have a all class constant. We're going to have a way to access that data. Cool. Like.all. I want to get back like some, like.all might be like a whole collection of like, there might be a lot of likes in there. I just want to get back some subset of them, the ones that pass the test I'm looking for. So I'm going to use the select enumerable method. I'm going to take each like instance and pick the ones where like.user equals self. Cool. So this is like exactly analogous to our implementation of tweets because it's the same type of relationship. Has many belongs to. Now, here's what I'll give you guys to do as the challenge. So we know how to do this, but now we're trying to get this. Are all the tweets that this user has liked. So the goal is here is to return a collection of tweet instances that this user has liked. Cool. I'll push up the changes from this code. It's the same repo from yesterday. And then we'll take a couple minutes to work through this problem. Cool. Cool. So, and actually, like, if you can find this lecture, if you go to learn, find where this repo lives. So if you go to learn, if you go to all the curriculum, and you'll see at the top in the schedule, there's a videos section with links. And this is going to have like the videos and links to the code. So this is actually going to be the same repository as yesterday. So you should be able to grab that repository just like there. Cool. Why don't you work with the person next to you? We'll take a couple minutes trying to write this liked tweets method. let's like, first I'm gonna go to the runner file and like add a scenario of like a user liking a tweet. So we'll make like, I'll make like another user, I don't know, T guy. Maybe there's a T liker on here or something. I'll call it T user, and I'll say like T user dot post tweet. I'll make T user like this other tweet. The user.postTweet method returns a new tweet. Awesome. Tuser.like tweet, and I'll pass in the tweet. Cool. Then I'll hit this pry. If I say like.all, how many likes am I going to see? Hey guys, let's go back. Cool. We should see the one created like. We have this one like. It has a tweet and a user. Cool. If I say, let's do this. If I say I take that user dot likes. I get back that same like, the one like that we have. If I did something like this, I'm gonna hit that pry. Hold on. User.like tweets. Why didn't I hit the pry? Self.likes. Cool. Cool. If I said self.likes dot first, now what type of object do I have? A like object. Cool. Given, let's put our problem aside for a second. Given a like object, how would, so just given this single like object, how would you just tell me the associated tweet? What method would I call on this? Dot tweet, right? This gives me back the tweet. So couldn't I do something like self.likes dot map each like to like.tweet? Self.likes gives me back an array of tweet objects. What I want to get back is those same number of objects, but I want every one to be different. I don't want the like object, I want to call the .tweet method on every single one. So this should actually do it. If I go in my pry here, thing, if I say my T user dot liked tweets, should give me back the tweet, great coffee, that this user liked. If I made, let's make like another like. Let's say tweet is equal to user dot post tweet. They'll say like really good coffee. Now we have a second tweet. This tweet could get liked by someone, but let's make another user that likes this. Other user is going to .like tweet given that tweet. Cool. So other user .liked tweets shows up this one, really good coffee. Our T user .like tweets gives me back the best coffee, one that they liked. Cool. So, and if we think like back at the beginning of this, what we talked about, like has many through, that's like really like what we're doing here. I'm looking through the likes to get to the tweets. I'm saying to find all the liked tweets, I say self.likes. I go over, look at the likes that belong to me as a user, and I find the tweet associated with each one. So the insight here was saying like, given one like, do I know how to find the associated tweet? And I think most people like got like, oh, like that tweet that gives you back the object. We just had to do this inside of a loop. Yeah. So now actually our other deliverables should be a lot easier. A tweet should have an instance method likers that returns a collection of user instances who have liked this tweet. So this is actually going to be like really, really similar. Tweet model. A tweet has many likes. That's going to be look through all the likes, find the ones where that likes tweet is equal to this specific tweet, the tweet that this instance method is being called on. Cool. And let's say def likers. How am I gonna? So this is like this is our has many through again. This is look through the likes to find the associated users. How am I gonna do this? Someone help me out. Tim?
Same thing.
Yeah.
Like that.
It's exactly the same thing. Take each like and call the .user method on every single one. Cool. So again, we're looking. If I want to, this is a tweet instance, and I want to get back all the users who have liked this tweet. That relationship is a tweet has many users, like likers we're calling it, through the likes. So first I write the code that'll get me over to likes using the like model. And then from there, I can go through that likes, the associated likes, to find every associated user. And that's like what a has many through relationship will do. You're going to look through the other kind of model. The single source of truth is that join model, the model that's joining the two things, and that is initialized with the two instances. Cool. This is what we're going to talk about for has many through. Next, we're going to move on to like some of the object architecture stuff. But before we do that, let's take like a 5-minute break, go grab some water or whatever, and come back. I'll set the timer. Cool. Yeah, 1 sec. Oh, it's okay. All right, guys. So I'm going to talk about this OO My Pets Lab. You'll see right here. Oh, weird. Uninitialized constant owner. Owner.rb. Oh, I must just say, oh. Cool. I'm passing all the tests. I'm not actually like super concerned about solving this lab and about like associating the pets to the owner. We're actually going to use this to talk about some of the other stuff like modules and variables and that kind of thing. So if I'm looking at this test, I see like a lot of repeated like cat, can initialize a cat, initialize with a name, can't change its name, it initializes with a nervous mood, and it can change its mood. A dog, you can initialize a dog, it initializes with a name, can't change its name, it initializes with a nervous mood, and it can change its mood. And I see for a fish, the same thing. Name, initializes with a nervous mood, and it can change its mood. And like seeing something 3 times in a row is actually a really good sign that we should like abstract this away. Seeing something twice in a row you might not like fully understand the abstraction yet. You just might have a hunch like, this might be something I'm going to duplicate a lot. But like 3 times in a row, you can think like, all right, this is some code I'm duplicating in many places. You can think about changing it. So like, what I'm noticing is that in every single one of these classes, I have the same code. So I'm gonna do this. I'm gonna touch a file called pet.rb. Before we go any further, so when I run the spec, it actually calls on my spec helper. I don't want to get too into this, but this is a pattern you might see. The spec helper is requiring this thing called the environment file, config/environment, and this is loading up all the files. I'm gonna require in here this new file pet, relative. So require relative takes a relative path, relative to the file I'm in, to get to the file I want to include. So I'm right here in config/environment. I want to go up one. Now I'm on the same level as config, lib, spec. I want to go into lib and into pet.rb. And I can actually leave off the .rb. It's implicit. It'll just assume that's the case. Cool. So I'm going to make a pet class. I'm going to go ahead and paste this code from cat straight into pet. Cool. And then so you guys did the labs on like inheritance and that kind of thing. So like, what does like inheritance mean? And in Ruby code, but also just like in the real world, like what's your understanding of inheritance? Yeah, dude.
You get certain traits from your parent.
Yeah, totally. So like you could inherit, some like pocket watch from your grandpa and say, "Thanks, grandpa. I'm gonna use this every day." So like we could say like a cat, and all we have to do is just like inherit like this. That's what that like the caret, and then we say pet. So and like we will use the same terminology, just like inheritance in the real world in terms of like parent and child or whatever, like ancestors. So like the cat class's ancestor class is pet. So I should actually be able to run these tests and still pass all the tests, even though I don't have any methods defined here. Which actually brings us to kind of an interesting point. If I open up IRB and I say like class dog and then I say like dog equals dog.new. So I can call on any kind of object, like a string. I can say .methods. It's giving back like an array of all the methods a string can do. So if I take my dog instance, and how many methods did I define in the dog class? 0, right? If I say dog.methods, how many methods, dog.methods.length? How many methods do you think I'm going to see? 58. So like, where are all these methods coming from? They're coming from Ruby. Every Ruby class inherits from these built-in, I can't do that? Dog.ancestors? Ancestor? Oh, I really thought I could do that. I could say like all the ancestor classes. Let me look that up real quick. Ruby ancestors. Maybe I have to call it in the class. Yeah, there we go. Cool. So like even though I made this dog class, I didn't find any methods in it. Every Ruby class just implicitly inherits from this class called object, which inherits from this class called kernel, which inherits from this basic object. Every single Ruby object does that. So I could do the same thing for like Ruby's built-in string class. And I'll see like this has the same ancestors. Some different ones. There's one called comparable as well. But that's where like all these methods are coming from. So we did the same thing here. Every class has these kind of implicit ancestors, and then we just wrote this in as like specifically has these ancestors. So I'm going to go ahead and add this to all my classes. And I should still be able to pass all these tests. Awesome. But now, like, this brings us to an interesting point. What if I wanted like a cat to have, or one of these classes, a cat to have like something unique about a cat that like other pets didn't share? Like, cool, has some of this stuff, but like, what if like I wanted to initialize a cat, and when I initialize a cat, I wanted to give it num lives is equal to 9, right? Cats have 9 lives. Let's give us an attribute reader here. Num lives. Something specific to a cat. Any guesses what's gonna happen when I run the RSpec test? It's gonna fail. Yeah, wrong number of arguments. Like, given 1, expected 0. So like in the specs, they tried to say cat.new and they gave it a name, just like it was expecting for the other pets. But then we redefine. So what does this tell us about like the order Ruby treats things in? What initializing method did it look at as the kind of like source of truth to use? This one or this one defined here? The one in cat, yeah, the one defined like further down, the one that's like closer to the actual cat.new and not the one further away in its ancestors. So if I wanted like, so that's gonna like, I'm not gonna get this error, but now I'm not really setting the name because I'm never like doing what I tell it to do here. Does anyone know how I can say like, go call the method in your parent? Super, yeah, super. And I'll go ahead and pass through that name to super. Awesome, cool. I believe you can even do just write super and it'll take all the arguments and just implicitly pass them through. Yeah, you can do that as well. I couldn't do something like this, call it with no arguments. It's not gonna work. Oh, I didn't save. That's gonna fail, but you can either be like specific about like what methods you would like to pass through, or you can just call super and that'll just pass through them all. So what this does is it sees super, it says I'm gonna go find a method that has this exact same signature that's called the exact same thing on my parent class. It does this here. Cool. So that's how we're gonna solve that. But then like, so there's like some problems with inheritance like this. Is that like I can only inherit from like one thing at a time. Like I couldn't have, you could imagine, and it just quickly gets unwieldy. So you can imagine like I also have like a class animal, and like I really want class cat to like have some of the methods coming from animal and some of the methods coming from pet. So you can imagine like, well then like pet is gonna inherit from animal, well then animal is gonna inherit from, and like this chain will get like real complex. And what's more, like what's kind of like seen as bad from a programming standpoint, these classes are so tightly coupled to each other. The cat class, if it has cat as an ancestor, which then has animal as an ancestor, which has like being as an ancestor, it knows all the information about all of those classes. And generally, we want to limit the scope of like what things know to like just what they need to know, and not other things. It'll make our code just a lot cleaner and like a lot easier to because everything isn't like so closely like tied up with other things. So there's another tool we can use to just say like include some of these methods in this class. What's that tool that I'm talking about here called? Starts with an M. Modules, yeah, that's, and like another term you might think of modules as like mixins. They'll allow us to, it's like less strict than this like hierarchical inheritance. It's just gonna allow us to say, hey, a module is one place where I define a bunch of methods. Let me pull them all in and include them in this class. And then you can include multiple modules, you can include them in different ways. So if I look at like the owner class, I'm doing this like pretty standard. The owner has a bunch of these class methods, and the owner can like save themselves, like we've seen in a lot of classes by now. This is a prime case for like repeated behavior. We're gonna see like, I really want all the classes to store everything do this like almost like database type thing where they're storing all instances of themselves. That's like gonna be logic that I'm gonna be duplicating in every single class. So this seems like a really good candidate for a module. By kind of convention, modules will often go in a folder called concerns. And they'll often be something that ends in ABLE. So like, if I was writing a find by name method that was going to be included in a bunch of modules, I might call it the findable module. Sorry? Yeah, enumerable is a module. Yeah, and from Ruby. So like, I might call this like I'm trying to like persistable. I might call this like I want to save all these things, or maybe like memorable. I think I'll go with like persistable. Persistable.rb. And all I'm going to do is say module persistable, and I should be able to go to my owner And before I forget, I'm also going to require that in here. So up, out of where I am, into lib, into concerns, slash persistable. Cool. And I should be able to do something like take all of this code here and paste it in here. I'm gonna run into some problems. What is self gonna be inside of this module? Any guesses? Yeah, well, modules aren't really like instances, but it's like going to be like the module itself. I don't want self to be the module, right? So I need to get rid of like all these selves. Def all. Cool. And then when I include this in here, I'm going to say, I should be able to get rid of all of this. I should be able to say extend persistable. I'm going to comment this here. Extend is the word we use to say, hey, the methods I'm importing in are class level methods. Extend signifies class level methods. Now you can imagine if I like went to my cat class and extended persistable and went to my dog class and extend persistable. Do I want to define this right here? I don't think so, right? I think like I need to, this is something that actually the class is going to have to be responsible for. I'm going to have to say, define this here so that this owner class stores its array of all the owners. I won't be able to share, I can share methods, but I can't share like the same data. That doesn't really make sense. And to change that, to access that data, I'll be able to use what's called a class constant accessor and just write that. So if you guys haven't seen that before, it's a feature of class constants. If I have some class Zorp, and I have like a class constant inside of it, I can access that class constant with the class constant accessor, which is just writing those two colons. Cool. That's all that's doing. So I'm going to say reach inside of the class, reach to that class constant, and return me that array. So I think I still should be able to pass this test. Oh, no. Uninitialized constant animal. Oh, because I wrote that in pet. Cool. We're actually still passing all these tests. There's one more thing I don't love about this current implementation, is that it seems like this should really be like part of the logic of the module, right? If this module is like all the stuff that is contained in one place for how instances are going to persist themselves to make classes persistable, it seems like I should really do this inside of the module. I'm going to say self.class all shovel in self. Does anyone see a problem here? Think of how I'm like, how am I importing these methods from the persistable module? What type of methods do I think I'm importing? Class methods, right? Yeah, this like kind of needs to be an instance method, something that's called on the instance. So you could imagine making like a separate module or something. Often what's done is to define the modules inside of each other. So I might say something like module persistable. Inside of here, I'll have a class methods. And let's just confirm that this works with our current implementation. now what I'm gonna extend is persistable, just the class methods. We should still pass the test. Cool. And now I'm gonna also make a separate submodule in here for the instance methods. And this is like how, if you were like writing like real production code, you're going to organize your code together into these modules. Like really soon, in about like, let's look up the Sinatra source code. In about like 3 weeks, you'll be learning like Sinatra, which is kind of like, if you guys heard of Ruby on Rails, it's like similar to Ruby on Rails. If we look at the Sinatra source code, where is it? Examples, it's gonna be lib, Sinatra, base. Sinatra is a module which has these subclasses inside of it. So we're gonna be like writing things in our code that are gonna be like, we're gonna define some class called like class application that's gonna be inheriting from like Sinatra : base. And that's all that means. It means there's like a module or class defined within the Sinatra module. And that's called like namespacing. We use it to like keep our code like organized and like it's clear to anyone. Like if my code looked like this, it's like, where is that base module coming from? Like I have no idea. This is pretty clear. This is coming from Sinatra base. And then I'm not gonna conflict because there's also another thing, another module, like we might say class user, and that might inherit from active record base. And because they're namespace under these modules, there's not going to be like conflicts like that when we're like importing a bunch of different gems. So this is a tool you'll see like all the time in like real code. All right, so we have this instance methods module where we want to do something like this. We want to say in initialize. What we want to do is say self is going to be the instance now. Dot class, I want to call that all method, and I want to shovel in self. I'm going to go here. Does anyone know what the word is to say like, hey, bring in some instance methods into my class? Include. Include persistable : instance methods. And I'm going to say include signifies we're importing instance methods. And now I should be able to get this out of here and say like call on super. No. Let's see. Wrong number is given 1, expected 0. Do I have to say, that's a good question. Do I need to define this here? To like just take like some args. I probably could do something like this. Is that right? Cool. So I'm just saying, hey, this method's going to take like any number of arguments. I don't really care. I'm not like using them, but just so the Ruby code works. Cool. So I think that's like a big improvement on this owner class because we wouldn't have to rewrite this code every single time if like there was like 12 more specs about like cats should be able to persist themselves, dogs should be able to persist themselves. I could reuse this code in the same place, and I wouldn't have to repeat myself. And that's like a big principle. People will say like keep your code dry, DRY. It stands for don't repeat yourself. We want to think about things where like we see repeatability, wrap them up, and use that same code so we don't have to write the same code over and over again. Inheritance is a way to do that, as well as modules. Cool, so that's for that section. The plan for, it's Friday, for the weekend, we're going to deploy a bunch of more labs to you. Many of them are marked bonus. They're bonus, they're not mandatory. That's after like a few minutes when lecture's over, you guys will have all of our object-oriented Ruby labs. You can do the bonus, you can, if that's what you want to do. If you decide that, hey, I'm not going to do the bonus, I want to go back and just like solidify my understanding of the previous stuff and just be like as good to go with OO Ruby as I can, that's totally fine as well. But in a few moments, you will have all our OO Ruby curriculum. We're going to start next week talking about SQL. It's a little bit of a different topic. It'll feel different for about a day or two, and then it'll all start tying together. But really the goal for the weekend is just to be like as comfortable with everything we learned this week as possible. If that means I want to do the bonus, I want to explore more, or if that means I'm just going to like Any questions? All right, that's all for lecture. We have Feelings Friday. I know you guys don't quite know what that is yet, but you'll soon find out at 5 o'clock. Yeah, that's all. Cool. Thanks, guys.